Hi, welcome to Tammy the Tutor. Today we're in CC3, lesson 1.1.3. Number 19, use the graphs from problem 17 to answer the questions below. So number 17 is a problem you probably or should have done in class with your teacher and your classmates today. And I can't pull that up because right now I'm just on the homework section and it only lets me pull up the homework. But right here is what they're talking about. A says, how can the graph for the rule y equals 2x plus 1 be used, blah, blah, blah. Okay, so that was the graph or the equation right there. Y equals 2x plus 1. That's what you were focusing on when you were doing number 17 in class. And so we are going to work with how can we use that equation to predict the result for an input x value of 7. And how can the graph be used to predict the output y value associated with an input of 3.5? I know this sounds huge. It sounds awfully intimidating. Lots of words. What does it mean? So you may or may not have connected this from classwork just yet. We're still in the beginning parts of it, but they've actually given you a huge clue right here. They said, how can that be used to predict the result for an input x value, and then for an output y value. So let me just give you some very explicit information right now that's going to help you. Another word for the x value, when you're making the graphs, you've got your x and your y, right? So I know that you understand the x and the y and what they're talking about with that. But they're going to bring in some new language now. Another word for the x value is input. Another word for the y value is output. So anytime they're talking about input, don't panic. It just means the x. And look at this equation they've given you right here. You've got your x right here and you have a y. So it's not going to be that difficult to plug in what they're talking about. For instance, it says, how can that graph be used to predict the result for an input of 7? Does input describe the x or the y? Right, the x. So in your equation, y equals 2, instead of an x, I'm going to write a little 7 in its place because for the x value or the input, they wanted to know what would happen if that were actually a 7. So you plug a 7 in its place. And then you could totally do some multiplication and some adding, and then you'll know what the y is. But that's not really what they're asking yet. I just want to connect these dots for you because they're just kind of going in circles and talking about so many big things, and you're probably going to get frustrated. I don't want you to get frustrated. Before I move on, though, let's also look at what that means when they talk about the output y value. I'm going to bring this same equation in, y equals 2x plus 1, but now they're saying they want the y value or output to be associated with an input of 3.5. So we're going to figure out our y or our output by using an input or the x of 3.5. Okay, so again, we could totally figure out the y value by doing math right here. But they're saying, could you actually just use the graph to figure it out without plugging in numbers into the equation? And so I love that they have, look here, they've got the graph of this line right here, y equals 2x plus 1. If you were to graph it, this is what it looks like, okay? So let's go back and look at the question again. How could you predict the result? Okay, the result, do you see, will actually be the y. Like if you put something in for x and you solve all of this, the answer or the result would be what the y is. Just let that sink in and see if that makes sense. Okay, well, if this is already graphed, this line right here, and they're saying, what if I have an input of 7? Again, guys, does input mean x or y? It means x. So I am going to come to my x-axis, and I am going to find that 7. Okay, so do you see how these are labeled? if that's 10, these are 2, 4, 6, 8, 10. So we need to find 7 on here. So 2, 4, 6. The 7 would be perfectly right here in the middle. You guys see that? Okay, I'm going to go straight up until I see where that point hits. Right here. Now go to the left because this is your Y or your output. So when you had an input of 7, your output or your Y is 15. Okay, I'm going to write that down really quick. But also, let's just check our math. We could have just said 2 times 7 is 14 plus 1, yep, is 15. So you could actually solve it by using the equation in front of you, or once it's graphed on a line, you could easily find it that way as well. Okay, and they're just wanting us to practice using our line on our graph to do it. Okay, so now let's see what happens if we have an input right here, an input of 3.5. So let's go back down here and let's look at our y-axis and let's figure out where 3.5 would live. Now, if these are scaled by 2s, if this is 2 and that's 4, perfectly in the middle would be 3, but that's not just a 3, it's a 3.5. So now I need to go halfway between here and 4, and that's going to be about, oh, it's hard to do with this. About right there-ish. Now, I'm going to go straight to the top until, oh, let's see. It would be about right here. Yeah, that's where it crosses that Y. Now go to the left. Let's see. Go to the left. What is this point on your Y-axis? Can you tell that these are actually being scaled by 1s? Because if this one right here, oh my goodness. If this one's a 5 and that one's a 10, then it's 6, 7, 8, 9, 10. So let's go back up to this point right here. And so right here would be your 8. Okay? Again, I found my 3.5 on my X and I went straight to the top until it crossed over. And then that represents an 8. Okay. Let's do the math really quick. Let's see if this actually equals an 8. Well, 2 times 3.5, well, 2 times 3 is 6. 2 halves make 1 whole. 6 and 1 is 7. Plus that 1 is 8. Okay? So you could have found it for sure easily by doing the math with your line, but they wanted you to practice using your graph. Okay, so for B, if you wanted an output of 7 for this rule, what would you need as your input? So 7 is our output, guys. So where Y is, I'm going to put 7. And I'm going to do the rest of it as is. They're saying if I have a 7 for my output, which is my Y, what is my input, or what would my input need to be to make this equation true? Because input and X are the same. So this time they're not saying use the graph. So that means they're okay with us just using this equation and doing a little bit of algebra to solve for X. So I want my X to be positive. So what I am going to do is I want to get rid of it on this side. So I have to add an X. So if I add it there, I have to add it to this side. A negative X and a positive X cancel out or adds up to 0. On this side of the equation now, I have a positive X and I have a positive 7. And over here now, I just have a positive 4. Okay, so X is in its rightful place. Now I want this 7 to move over here with the 4. So how do I get rid of a negative 7? I subtract it, but what I do to one side, I must always do to the other. That adds up to a 0. I'm left with an X equals a negative 3. Okay, so if we want our output to be 7, our input needs to be a negative 3. Okay, now let me erase all of this and make room for C. For each of the rules in parts A through E of the problem 117, where does the graph cross the y-axis? Okay, I have right here problem 17 that was in your lesson in class today. And I'm going to write A through E, and I'm going to write down exactly what those rules or equations were. And we'll go from there. So A was the y equals 2x plus 1, which was what we were using for A. B is y equals negative 2x. C, y equals x plus 4. D, negative x plus 4. E, y equals x squared. My y didn't show up here. Okay, so based on just these rules, they want us to know where does the graph cross the y-axis. So if we were to use these equations and we were to create a line on a graph, see here, do you see how this line comes down and it eventually crosses the y-axis? Remember, the y-axis is this vertical one straight up and down right here. Do you see right here? It's where it crosses the y-axis. That is called the y-intercepts. It literally intercepts the y line at a positive 1 on the y. Okay? Think about this for 1 second. If this line crosses the y at a positive 1, and you can see it, it really does. Go look at the equation for that one. Here was the equation. Do you see a positive 1? Right here. Does that possibly mean that when you have one of these rules or one of these equations, this number over here, will that always tell us where the line will cross the y-axis? Might be onto something, guys. Now, I'm not going to graph each of these lines because I don't think that's what they're wanting you to do. They want you to kind of notice that pattern. So I'm going to skip down here to C. I'm going to tell you this first. Y equals mx plus b. This right here, you guys, is the equation of a straight line. These are all patterned after this. And when you graphed one of them, look here, it is a straight line. It's slanted, but it's a straight line, okay? So every time you graph one of these that's in this form, it's going to give you a straight line. It'll always start with y equals, and you'll have an m and a number, and then your x. And then sometimes you'll have a plus or a minus another number. Sometimes you won't, and I'll tell you what that means. But for now, just notice how this really does, this one and this one, is modeled after this pattern. Okay, so like let's look at A. There's your y equals, instead of an m, there's a 2. Okay, and that m means something. And there's an x plus not a b, but a 1. Okay, so there are 2 things that you are going to start learning about this. You're going to have to figure out what that m represents and what this b represents. That m, another word for that is slope, and you will see what that means later. Right now is not the time to worry about it. But b is called your y-intercept, guys. It's where that line crosses the y-axis. Okay, so let's skip down to C for just a second. If this is patterned exactly after this one, and the y-intercept, or where the line crossed the y-axis, was the 1, what do you think that y-intercept would be for C, guys? Positive 4. Okay. Up here it was that 1. What do you think it would be for D? Positive 4. Now, if you notice, B and E, it's got the y equals a number and the x, a y equals a number. If there's no number in front of the x, it's a 1, okay? But there's just no need to write the 1. It looks kind of silly and it's obvious there's only one x square there, okay? But there is a number, just so you know. They just don't have a plus minus another number here. There's no plus or minus another number here. So I wonder what that could mean. It has to cross the y-axis somewhere. So if it doesn't have a number there, that means it crossed it at the 0. But there's just no need to write the 0. If there's nothing there, it's just that assumption that it's going to cross right through that 0. And that means it would have crossed right here on the 0. It like would have gone through right here instead of the 1. Okay? So those are the answers for A through E. Where does the graph cross the y-axis? At the 1, the 0, the 4, and the 0. Okay. That was a long explanation, guys. I'm really sorry, but there's a lot of things going on here, and I just want to make sure if you just have little gaps in your understanding, because I know how it feels when the class is moving on and you're like, wait, I just didn't understand that one thing. Okay. 20. Solve the problem below by defining a variable and then writing an equation. If you find this is too challenging, use the 5D process. Okay, no, we're good. I'm going to show you a way to do this that's pretty logical. And again, these can feel intimidating at first, but I'm going to show you how to break these down, guys. These actually are kind of one of my favorite things too. It's just like solving a puzzle again. There's a real way to think about it, a real way to do it. And when I go through and show you, you're going to go, oh my gosh, it's not that difficult at all. Okay, it says define a variable and then write an equation. So before we can solve it, we have to figure out what our variables are going to be and figure out what that equation looks like. Okay, it says Jabari is thinking of 3 numbers. Okay, already right there, I know I'm going to need 3 different variables because I need to represent 3 different numbers. We can just say X, Y, and Z. You could say A, B, C, whatever you want, but they want you to define those variables. And so let's read the rest of it so we can learn a little bit more about them. Okay, it says the greatest number is twice as large as the least. The middle number is 3 more than the least. The sum of the 3 numbers is 75. Okay, you know what? Some of you might prefer to do it this way. So there's a least number, a middle number, and the greatest number. It might make sense in your brain to say the least, the middle, and the greatest. That could be your 3 variables. It doesn't matter. As long as whatever letter you have assigned them, it makes sense to you and you can keep up with it, okay? So here's the deal. We want to write down what we know about each of these numbers. Now, these kinds of problems are always going to give you very specific information about, like if you've got 3 variables happening like we do, they're going to give you information for 2 of them only, and one of them, they'll give you nothing. And I'll show you why and what that means and what we can do with it. That's a good thing, I promise. Okay, so the first thing they're doing is they're telling us something about the greatest number. So we're talking about this guy. So we're going to write something to represent him. The greatest number is twice as large as the least. So here's what we know about the greatest number, guys. It's 2 times as big as whatever the least number is. Whatever that least number is, this one's multiply it times 2. It's twice as large. Okay, makes sense? Okay, the middle number is, let's see what they're telling us, 3 more than least, okay? The middle number, here's what they're telling us about the middle number. It's 3 more than whatever the least is. Whatever that least number is, add 3, because this one's got 3 more to it. You just have got to learn how to read sentences, word sentences, and turn them into math sentences, okay, guys? And it gets easier and easier the more you see different examples. Now, the sum of the 3 numbers is 75, find the numbers. They didn't tell us anything else very specific about the least number. So guess we're going to label that one just L. We don't really know anything else about it. We're just going to call it L. Every one of these problems is patterned after something like this. So don't freak out when there's one, you're like, I don't know what to write about it. It's okay. Just call it L. Because now watch this, you guys. We're not going to use G and M and L. We're going to use these. This is our new information. Okay. It says if I were to add all 3 of these together, because it says the sum of them, the sum means adding, it would be 75. So you're saying if I add the L and the 3 plus L and the 2L, it'll equal 75? Well, let's check. This is our equation. We're going to say L plus 3 plus L plus 2L. And if I add all of these together, that should equal 75. Now, look how beautiful this is. Guys, we only have one variable in here. That's good news because now we can actually solve it. If I had an L and an M and a G, I wouldn't be able to solve this equation. Okay, now we can solve for L. Once we know what L is, we can go back and plug it into the other two and figure it out. So let's do this. Combine like terms. How many L's do we have total? So we've got 1, 2, 3, 4. 4L, and then we've got that plus 3 equals 75. Let's get rid of this 3 by subtracting it from both sides. 4L equals 72. Now let's divide both sides by 4. L equals 4 goes into 7 once, subtract 32. That would be 18. Okay, so we know one of the numbers is 18. So let's come back up here. If L is 18, we can figure out the middle number because that's 18 plus 3, which is 21. And then the greatest one was 2 times the L, which was 18. 2 times 18 is 36. Now, here's the really fun part. You can go back and check your work, and you can always make sure you did this correctly. They literally said, I've got 3 numbers. If I add all 3 of them together, it equals 75. So let's test it out. Let's go 18 plus 21 plus 36. Let's see if this equals 75. 8 plus 1 is 9, plus 6 is 15. 3, 4, 5, 6, 7. It indeed does equal 75. So it says find the numbers. So when you're answering this, you could either just simply do it like this, or you could have said my least one equaled 81, my middle number was 21, my greatest number was 36, whatever you want. But see, it's not that bad. Okay, 21. Okay, Letitia's friend Brandy forgot to make up a test and had these scores 80, 92, 91, 75. Okay. Calculate Brandy's mean. Does this mean score really represent her abilities? Why or why not? Okay, so let's first talk about what a mean is. When you have a set of data and you want to find the mean, that means you're trying to find the average. So if these are the scores that she has made on all these tests, she's probably trying to say, like, what's my average? Like, I make some high, some low, some in the middle, but what would be my average in the middle? So how you find the mean or the average is you add up all of your numbers from your data, and then you have to divide it by the number of numbers that you were adding up. So that would look something like, I'll do it like this. Okay, so we have an 80 plus 92 plus 91 plus 75 plus 89 plus 84 plus 0 plus 85. Those are all her scores. Now notice I added the 0 in here as well. I know that adding a 0 doesn't change anything, and so it's tempting to leave it out. But don't leave it out, because when I said you have to go back and divide it by the number of numbers you added, 0 was really, truly one of those numbers. So you need to count that as it. So I would not have counted that if I had left it out. There's 1, 2, 3, 4, 5, 6, 7, 8. I'm dividing all of that by an 8. If I had divided it by 7 because I thought the 0 didn't matter, then I would have gotten this incorrect. Okay. I'm actually going to just quickly use my calculator on my phone because I know you guys know how to add, and I know you have access to that at home too, and I just want to quickly move on. 92, 91, 75, 89, 84, 85. So that equals 596. Let's divide it by 8. So her average score is 74.5%. Do you notice they said, does this mean score really represent her abilities? Why or why not? Okay, let's think about it logically. Look at her scores. She's got 80, 89, 84, 85. She's got a 92 and a 91. Those are pretty high scores. I mean, she did get 175, but that's all, just 175. Mostly she's getting 80s and even into some 90s. So you're saying her average score that she makes when she takes a test is a 74.5? So that doesn't really make sense, right? And it's because that 0 brought her average way down. But that 0 may have probably wasn't because she took the test and knew nothing and just did so poorly. It's probably because she just missed the test. So that really doesn't represent her actual abilities, right? So that's what you can say for A. No, it doesn't represent her abilities. That 0 was probably a missed test. Her abilities obviously are higher than that because they are almost all way higher than that. Okay, so B, Brandy persuaded her teacher, Miss Juarez, to allow her to make up the missed tests. See, there's that missed test. And when she did, she got a 78%. So calculate her new mean. Okay, I'm going to come down here and I am going to erase that 0 because she made that test up and she made a 78%. Now, I am going to redo all of this. Okay, let's say 80 plus 92 plus 91 plus 75 plus 89, 84, 78, and 85. Okay, so now she's got 674 divided by 8. There's still 8 numbers. Her average is 84.25%. Now that rings a lot more true. Doesn't that make way more sense talking about what her abilities are? Okay, see, what difference did the 0% score make? Does this new mean represent Brandy's ability more accurately? Okay, yeah, that 0 brought her true average considerably down. And so it wasn't a true portrayal of what she was actually capable of doing. Does the new mean represent her ability more accurately? Absolutely, yes, it does. This is the true average of her scores when she actually sat down and took the test and got the grade that she got because that's what she knew. Okay? Okay. (22) The area of a rectangle is 24,396 square centimeters. If the width is 38 centimeters, what is the length? How do you know? Okay, so anytime I have a problem like this, guys, I always draw a picture. I can't tell you how many times that math problem seems like a mystery to me until I start writing pictures down and putting pieces together, and then I can see it. Now, not all of you may need to do that, but I'm a very visual person, and I'm just telling you what helps. If you've ever struggled, maybe you should try this. Okay, the area of it inside. So you guys remember that the area means the inside measurement. Like if I were to fill all of this in inside, is 24,396. And how do you find area of a rectangle or a square? It's the same thing. Squares and rectangles aren't the same thing. Finding the area of the two different shapes is the same thing. Let me clarify that. The width is 38. So depending on how I drew this, I'm going to put the 38 on this side. Okay, I put my labels here. What is the length? So we just have to find what the measurement of this side is. So if area is found by multiplying length times width, we have the area, we have the width, we just need the length. So now we just need to divide 24,396 by 38. Okay, I could totally use my calculator, so could you at home. I'm choosing right now to do long division in front of you because I find that a lot of students your age and even more into high school, don't feel very confident with long division, I'm just assuming you've not been given enough practice, like probably that 5th grade year when supposedly you're supposed to master it. And I'm finding more and more these days, kids are like, we just didn't do it that often, so I never really got it, or it's been so long that I've forgotten. So let me just give you a refresher, because sometimes you actually are forced to do long division in a test or in school. So I'm looking at this. There's no way. I don't know how many times 38 goes into this huge number, guys, but I got to start somewhere. So I'm looking at it. Can 38 go into a little bitty 2? No. So I'm going to move over to here. Can a 38 go into a 24? Nope. So move over one more. Can 38 go into 243? Yes, it can, several times. So let me try to talk you through what my brain is thinking. I'm going to put like a little line here just so that you can kind of know that I am thinking only about 243. This is where I kind of round things off in my head. 38, in my head, I think about it as a 40. It's kind of a friendlier number. And 243, I round it down to about a 240. Okay. Now, I can totally estimate this now. As a matter of fact, I can look at it like a 4 and a 24, and I know that a 4 goes into 24 6 times. So that means the 40 goes into the 240 6 times. Okay. So I'm going to just try a 6. Now, when you estimate and do this, it's not always the perfect correct number the first time, but that's okay. It totally gives you a starting point that is so close. And if it doesn't work, then you're automatically going to know, oh, I needed to go one higher or one lower. Okay. And this is just trial and error, and that's just the nature of long division. So now that I have guesstimated that it's a 6, I'm going to put my little multiplication sign here. That tells me that I immediately need to multiply 6 times 38. And you could come over here on the side and do it like this if you want to, because that's maybe the way you're used to doing it. You can use your calculator. I'm doing it like this, but without rewriting it over here. Watch what I'm doing. I'm going to go 6 times 8 is 48. Write my 8, carry my 4. 6 times 3 is 18, plus 4 is 22. There's no difference than doing it like this. I did it upside down, but it's still the same thing. I did 6 times 8 is 48, and you're doing 6 times 8 is 48. Write your 8, carry your 4. And then I did 6 times 3 is 18 plus 4. You're doing 6 times 3 is 18 plus 4. There's no difference. It's just a little upside down. And if you can just get yourself comfortable with it, it just saves a little bit of time without having to rewrite this over here and coming back. It's already here in front of you. If you can just learn to do it, it's easier, I promise. Subtract, that'll be 13 minus 8 is 5. 3 minus 2 is 1. Okay, so we did it right. 6 is the right number because there's just enough left over. It's not more than the divisor. Your next step is to bring down your next number. Okay, now we're going to do it again. So now I'm thinking in my head, 40 goes into, I'm going to round it up to 160. Well, I know 4 goes into 16 4 times, so that's a really logical guess for my next number. So I'm going to say 4 times 8 is 32. Write my 3. 4 times 3 is 12, plus 3 is 5. Look at there. 7 left over. Bring down your next number. And 38 goes into 76. Well, I just can tell it's actually twice. 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. Okay. So our answer, our length is 642 centimeters. If you really want to check your work and make sure, you can come over here and say 642 times 38. Make sure it equals this big number. Could have used your calculator. They're not so concerned at this point in your life if you know how to multiply or divide. They totally assume you can do it very proficiently. They want to know that if you read a word problem like this, would you know what that means, how to set it up, and do you know what math operation to use to solve it? Okay, so that was, ask yourself, if you're not great at long division, okay, you can work on it, you can get there, you can use a calculator, whatever. But did you recognize, oh, I can find area by multiplying length times width? I'm given the big area. I'm given one of the sides. So if I divide, I'll find the other. That's the big thing you need to ask yourself. Are you recognizing? And if so, then you're on the right track. You're good to go. Okay, one more. Okay, 23. Copy the number line onto your paper. Locate the following numbers by placing the lowercase letters A through F on the number line corresponding to the values given below. Part A is done for you. Okay, great skills to practice, guys. By now, you really should be feeling more comfortable with this kind of thing. And you see how they have this calculator X'd out. They're going, we really, really want to see what you can do without using a calculator. It's super important. We expect you can, so you really need to try and monitor and test and say, okay, where am I? As compared to where I should be. And if you're finding that there are some of these little skills that you're still kind of missing, okay, I'm helping you a lot, right? So if you're paying attention, you're picking up a lot of things from me. Or you could even go, oh my gosh, there's that one thing that every time it really worries me and I'm not good at it. So I'm going to take initiative for my own learning and I'm going to find a way to practice that skill until I feel really good about it. Okay? Okay, so A is 2 1/3. Oh, they've already done that for us. So you see how it's 2, but then a little bit more. So between the 2 and the 3, they went a third of the way through. It's almost like if you had the 2 and the 3 and you had to divide it into 3 equal sections, because do you see the denominators of 3? That always tells you to divide it into 3 equal sections and then only just make one hop because it's 1 out of 3. And that really looks pretty good, about 1/3. Okay, let's look at B. Negative 2.7 or negative 2 7/10. So right now, I already know I'm at least right here on that negative 2. But I'm not just at negative 2. I'm at negative 2 and some. So I'm going to have to go over somewhere between the negative 2 and the negative 3. Okay? So think about this for a second. I kind of like that visual I gave you of the 1/3 and how to divide it into 3 equal parts. What if we wrote this like negative 2 7/10? So that would tell you between your 2 and your 3, try to picture if you had to divide this line into 10 equal parts, where would that 7 live? So here would be a half in the middle, but we need to go a little bit more to kind of be that 7. Okay, now and this is certainly not going to be exact, guys, but they just want to know that you can show you know about where, right? So that would be negative 2 and then 7/10 over. Okay, so let's look at C. 9/10 minus 4/100. Well, first of all, we just need to do the subtraction and see what the answer is. And then whatever the number is, we'll find it on the number line. So big thing with subtracting with decimals, guys, is remember, line up your decimals. Line up your decimals. Place value is everything. See how that looks a little bit wonky when I line up my decimals? But that's okay. Goodness, my pen is a little bit off here. Because the 9/10, it's still a bigger number than the 4/100. So all you need to do when it looks like this is just add a 0. Because I haven't changed the value. 9/10, now it says 90/100. They're equivalent anyway. It's the same thing anyway. Well, what is 90 minus 4? It's 86. And if you have your decimals nicely lined up, then you know you're perfect if you bring it straight down. But this is a negative number, guys. So forget the negative for just a second. If I just had 86/100, or, think about out of tens, it's somewhere between an 8 and a 9. It's a little bit more. So you could almost think about it like this. So let's look at our number line. We're in the negatives, but it's not big enough to be a -1 yet. It's almost there, but it's not big enough to be a -1. So it's going to be somewhere between your 0 and your -1. So if this were divided into 10 equal parts, where would the 8.5 live? So 8.5 would be about right here. I mean, it has to be a little bit more than where we said the 7 was on this side. Maybe the 7 should have come over a little bit more here. Okay. D, negative 2/10. Oh, sorry about that. You're probably thinking I'm going crazy here. It's between the 0 and the 1 and the 8.5, about right here. Okay, there we go. So negative 2/10, so negative 2/10. It's not enough to be a whole negative 1 yet. But if it's divided between the 0 and the 1, if it's divided into 10 equal parts, where would the 2 live? And so that would be like 1, 2 right here. It's in the negative 2/10. Okay. 33 1/3% of 12. Ooh, there's a lot of things going on in this one. First of all, if no one has ever made this clear to you, in math, every time you see the word of, guys, all that means is multiply. Every single time, I promise. So I could rewrite this as 33 1/3% times 12. Okay, that makes a big difference right there, right? Are you feeling better about this? The only thing you need to remember is you cannot multiply a number if it's in the percent form. You can turn it into a fraction or a decimal, and then you can do your multiplication. But if it's in the percent form, you can't do the multiplication yet. So I like the decimal with this one. The first thing, though, is I want to deal with that 1/3. If I were to rewrite 33 1/3 just as a decimal, it's going to look something like this. Anytime you have 1/3, it's the same thing as this. And if you've got 2/3, it's going to be like this. And then obviously, if you've got 3/3, it's just one whole. But you'll get really quick and easy with a lot of these things. When you see 1/3, you're going to know, oh yeah, that's like 0.3333, keeps going forever. The 2/3 is 0.666, keeps going forever. But all I did was change this little fraction into a decimal. This is still a percent, you guys, okay? I'm almost where we can do this. Now, we want to turn this percentage into a nice, better decimal, okay? So to turn a percent into a decimal, you find where the decimal already lives in the number, and we've got it right here. And then you want to make 2 hops to the left because you're basically dividing by 100. So 100 has 2 zeros. Dividing means you're going to the left. So 1, 2. So now my new number looks like this. Now we are totally ready to do some multiplication. I don't have tons of room. I'm gonna make a little bit of room for myself here. When you are multiplying decimals and whole numbers, there's no rule that says you have to line up decimals or anything. It does not matter. As a matter of fact, don't think about it that way. You want to do normal multiplication where the number with more numbers, more digits is on top because that's where it's going to be easier. And this one has more digits on top. And then you put the 12 down here. And then I kind of go sneak that little decimal back so I don't forget it. And just do multiplication as normal. 2 times 3 is 6. 2 times 3 is 6. 2 times 3 is 6. Now we're down here. We're done with our ones place. Place value holder, because now I'm multiplying by the 1, which is in the tens place. So it needs to start in the tens place here. That's why we always put this place value holder. That's the ones place, but we're done with the ones. We're starting on the tens. 1 times 3 is 3. 1 times 3 is 3. 1 times 3 is 3. Now we can add our partial products. Okay, now that we know what the actual number is, we need to decide where does our decimal going to live. So go back to your numbers and find where your decimal lived in here. Okay, I know it looks like there's a decimal here with our 12. That was just me pointing when I was doing multiplication. Our 12 did not have, see look, our 12 does not have a decimal. Our 333 does, and it's right here. Okay, so start to the right of that number and count how many hops it takes to get to that decimal. And that's 1, 2, 3. You see how you start on the right-hand side and count how many hops to get there? There's nothing in the 12, so we don't need to count for that one. Come down to our final answer and start on the right-hand side and do the same thing and go 1, 2, 3. And that's where your decimal lives. So the answer for all of this, boy, has taken a long time, is 3.996. You really can think about it. It's almost a 4, but not quite. So we're going to come over here to our 4 and just right before it. Oh, I was supposed to be putting the letters up here. Sorry about that. Hopefully you were doing that along the way. Let's see, F, 7/10 plus 2/3. Okay, we just have to do the actual addition here. And once we know what the answer is, we'll know how to place it on the number line. Okay, we're adding fractions with unlike denominators. Okay, I want you to go back to your 5th grade years, because a little bit of 4th, but mostly 5th. You kind of mastered this. You got to get a common denominator between a 10 and a 3. You want a number that they both divide into. And so I always start with the bigger number first, okay? I actually even start with the big number. And I'm like, well, I know a 10 can divide into a 10. Can a 3 divide into a 10 evenly? No, it can't. Okay, so what's the next multiple of 10? It's 20. Okay, I know a 10 can go into a 20. Can a 3 go into a 20? No, almost, but not quite. So now 10, 20, 30. I know a 10 can go into a 30. Can the 3 go into the 30? Yes. That's called the least common multiple. So my new denominators are going to be 30. I'm going to change them to 30. So I'm sure most of you already understand this. You know what to do. If some of you are still having a little bit of a problem with this, I'm going to try to explain it. This is not normally the way I like to stack them up. I like to use the giant one, but I didn't have a lot of room, so hopefully you can follow me. So I want you to notice that the denominator is the number that we just changed, right? It was a 10, but now it's a 30. How did we get from that 10 to 30? We multiplied it times 3 to get there. If you change your denominator by multiplying it times 3, you need to change your numerator the same way and multiply that times 3. 7 times 3 is 21. Okay, so now 21/30 is equivalent to 7/10. We're going to do the same thing to here. How did we get from 3 to 30? We multiplied it times 10. Okay, great. Let's change our numerator the exact same way and multiply that times 10. 2 times 10 is 20. So now when we add them up, we've got 41/30. We still have a little bit of work to do because that's really difficult for me to see how to put it on a number line. I need to erase something, give myself some room. Okay. There are several ways to think about it or to do it this way as well. A lot of you can do it mentally. In case some of you are watching and you're kind of going, oh, I'm not sure how to change this back into a mixed number. So I want you to remember, first and foremost, when you have a fraction, the fraction bar literally means divided by. That is a division sign, guys. So this says 41 is being divided by a 30. So watch. 41 is being divided by a 30. Guys, the number on top is always the number that gets to go into the bracket. Let me share a quick story because sometimes kids know they need to divide, but they can never remember which number goes where. I was just like that until I thought of this silly story. I get these silly stories in my head, but it truly helps. So I think about the number on top being kind of the king of the world. He's the top dog. He is just the cool guy. And he is standing on the shoulders of this poor little 30. This 30 is like the nobody. He's the slave. He just is, kind of a nobody. At least that's what the 41 thinks, right? He thinks he's the coolest guy in the world, and that 30 is just nothing. Well, all of a sudden it starts raining really, really badly. So that 41 says, hey, I am going to run and get under the shelter. So the 41 gets safely and nicely dry under the shelter while that poor little 30 has to sit out here in the rain and get wet because remember, he was the nobody. Okay, so that's just my little story to remember which one goes where. So 30 goes into 41 one time. 1 times 30 is 30. Subtract with 11 left over. Okay, so this goes in to 41 one whole time. And out of 30, I want you to notice 30 was my denominator before. It still is. The denominator never changes. There were 11 little guys left over that could not fit into a new group. So 41/30 is the same thing as 1 and 11/30. Okay, so I can look at this and figure out where this goes. So somewhere between 1 and 2, So think about 11/30ths. If I had 15/30ths, that would be exactly 1/2, right? Because 15 is half of 30. Well, 11's not that much smaller than 15/30ths. So without having to do more work and find the real decimal, which we could do, we could totally do that right now. But I'm trying to also teach you how to use shortcuts and use the knowledge that I know that you already have in your head. You just didn't know how to maybe connect it. So think about where 1.5 would have been. That would have been perfectly in the middle. You need to go over a little bit less because 11/30ths is not quite as big as 15/30ths or 1/2. And that would have been the F. Okay. That was a really big section, guys. Good job. I hope you go home and take a nap now. And I will see you next time.